Hello, I hope your February is going well. I'm Victoria weather meteorologist Ryan Henning, and as you might be able to tell with my big thick nerd glasses, I am here to talk to you about science. The last two days we've had posts about Central California, Visalia. We had a forecast yesterday, and then we talked about a road trip from Visalia to Yuba City today, and the valley, it's been kind of in the clear on a lot of the really rough weather that California has been seeing lately. There's been rain along the coast, and then there's been a ton of snow in the Sierra Nevadas. And that's kind of what I wanted to tell you, or talk to you guys about today. Why does it snow so much in the Sierras? There's so much of California is desertified and it stays dry and along the coast for so long. Why doesn't it rain there? I mean, they're right along the ocean, so you'd think, hey, maybe it should rain a little bit right here. Well, let's first talk about why Southern California stays so dry. And the big thing there, and you think of maybe like the Gulf Coast, they're right along a big body of water, and it rains all the time. In Louisiana, for example, they get big nor'easters up and down the eastern seaboard, and then they get thunderstorms in the summer. What's so special about them that is different about the West Coast? The big thing that's different out west is the ocean currents. It is simply much colder in Southern California, or in the Pacific off the coast of Southern California, than it is in the Gulf of Mexico, or even along the East Coast where the Gulf Stream rides along the East Coast, and then that's where those nor'easters track, is along the Gulf Stream. And then the northwestern end, I just pushed up my glasses like that just to give you the idea that I'm a super nerd. But as I was saying, those storms move up along the East Coast, and the northern end, which is often the snowiest, windiest end of the system, clips the East Coast, and then you get snow in New York City and Boston, and a panic ensues. But it's colder, so you don't get the development over the ocean like you do out east. Most of the systems that impact the west coast of the United States are born out of the Gulf of Alaska, and so all of the moisture that usually forms into some sort of atmospheric phenomenon hits the Alaskan Panhandle, British Columbia, or famously the Pacific Northwest, which is, of course, always raining. The Cascades kind of have a similar thing going on as the Sierras, where they get a bunch of snow, but that makes more sense, right? Because it always rains in Seattle, so you'd think the mountains just east of town, they're going to see a lot of snow. But in the Sierras, you don't think of a lot of snow because you don't think, oh, it rains a ton in Los Angeles, or it rains a ton in Fresno. But here we are talking about snow in the Sierras. And here's what it is. Have you ever, this is going to be a weird way to explain it. Have you ever looked at a can of soup? It's got different directions on how to prepare it. If you're in a normal place or somewhere that's high elevation. And the reason for that is that water boils at a different temperature at high elevation than it does at a normal sea level surface. I'm calling sea level normal, I guess. And that's because of the way that matter works. If we say the temperature that water boils at is 212 degrees Fahrenheit, but that's at sea level, because you can also boil water by changing the air pressure. Like if you threw water into space, it would boil pretty quickly because the pressure is so low, so the temperature that you need to boil the water is also much lower. And then that's how you get for any change in state with water. If you want your gases to condense into liquid water, then it's easier to do that the higher up in the atmosphere you go, which is why all of the clouds seem to have the same base. It's because all of the rising air parcels reach that lifting condensation level, it's called, at the same height. So that's basically what's going on with the Sierras as well. These fairly dry air masses are scooting across California and not really reaching the elevation that they need to lift, condense, and then release all that moisture onto the ground below them until they reach the mountains. So these systems can be pretty moisture rich coming across the Pacific, not drop anything on, Visalia like we talked about, or Merced or Modesto or anything like that, and then hit the Sierras and just completely lock up the Donner Pass area. It's because these air parcels reach the Sierras, they start to rise, they reach a point where all of the liquid in the parcel condenses and you start to get clouds, and it can keep going up, and then the air parcel just can't hang on to that much water anymore, and it releases. And another thing about being at high elevation is it's chilly, and since it's colder, then that's still the case. It's going to fall as snow when it condenses and becomes precipitable water. So you get a foot or 2 feet of precipitation because none of this moisture fell out across all of California, and it's very efficiently distributed across the Sierras. So then that's the other thing. If you have a system moving directly west to east, it's probably not going to bring a whole lot of moisture to central Nevada because it brought all the moisture to the Sierras. Or, if you've ever been to southern Utah, desert, that's kind of the situation that's going on. If you want to get moisture to those areas, you kind of have to go around the Sierras. You get a tropical system from Mexico, or the yearly monsoon, which uses a lot of Gulf moisture actually, but you just don't get those Pineapple Express type of systems that pound the Sierras. But I hope that helped or was informative or something, and you understand why the Sierras get a little bit more snow than you'd expect after listening to this. And to recap, it's because orographic lifting. The air parcels hit the mountains. Air doesn't go through mountains, it goes up and over, and as it goes up and over, the water reaches a point of its state of being where the pressure is reduced, so it has to condense. The condensed water forms clouds, and then it gets too heavy to be suspended any longer, starts to fall, and it falls through a cold air mass as snow. That's about it. So I hope the rest of your February goes really well. And maybe I will be donning these nerd glasses again sometime and helping you through some science. I'm Victoria Weather Meteorologist Ryan Henning, and I have a great evening.